So in the last lecture we saw the alternative fuels part of this module. In this lecture we will be taking a basic look at the engine control unit and the various sensors that are used in the engine control unit. Right? So what basically is an engine control unit? See, an engine control unit is also known as a engine control module. See, what basically it is a microcontroller or microprocessor. What does this microcontroller microprocessor do? It coordinates the functioning of all the electronics inside the engine, right? See, now in your engine there are a large number of processes that have to take place. For example, the valves should open, the air fuel mixture should be balanced, what should be the temperature of the air, that has to be checked, what is the pressure of the incoming air. Then in the exhaust gases, what are the constituents of the exhaust gases, what is the temperature of the exhaust gases, what is the temperature of the coolant, what is the temperature of the engine. All these things have to be measured. Till now, means before the advent of electronics, in the old completely mechanical cars, all these things were done mechanically, right? For example, for adjusting the air fuel ratio, you had your carburetor. But as we know, as we have seen, carburetors being mechanical devices are not completely controllable. We can control them to a certain level, but they are not completely controllable, right? This complete control can only be achieved if we use some kind of electronics. That is why this electronic control unit has been used. What does an electronic control unit basically does? See, an electronic control unit is like your CPU, computer CPU. In case of your computer CPU, see, whenever you want to type something, what do? You hit the key on the keyboard. So over here you have your keyboard, you hit say A. This information is not directly sent to the monitor, right? This information is sent to whom? It is sent to the CPU. The CPU reads this signal from the keyboard and then it sends a signal to the monitor, right? So this is how a CPU works. CPU receives information from an input device, takes the necessary action based on the program that is written. For example, if you hit A in your Microsoft Word, A is printed on the screen. If you hit A in some game, then it is possible that the person might move forward or left or right or backward, right? So that is what is happening. So based on the program that is written inside the CPU, inside the code, that is how it will perform. So there is an input device, there is a CPU, there is a code inside the CPU, and based on this code the CPU sends a signal to the output device. That is the same thing which happens in your engine control unit also. Engine control unit has several inputs. What are those inputs? It can be ignition switch, throttle position sensor, vehicle speed sensor, manifold air pressure sensor. There are so many sensors that are used. All these sensors collect their specific information and send it to the engine control unit. Based on this information and whatever the code is written inside the engine control unit, right? Engine control unit uses this code, and based on this code the engine control unit sends a suitable output to all the actuators. Based on this signal the spark plug will burn. Based on this signal the throttle will open. Based on this signal the injector will inject the fuel. This is how all this process takes place. Thus an engine control unit is kind of a head or a CPU which controls the working of the entire engine. Okay, see, there is not just one ECU, there can be several ECUs inside the engine. For example, there can be a ECU which controls the ignition process. There can be a ECU which controls the exhaust. What is the exhaust? And they communicate with each other. And overall, there is a central communication system which has all these ECUs. These ECUs communicate with each other also. And thus the entire process takes place. So this is how, and this is what is the function of an ECU. Basically, an ECU coordinates the working of all the different engine systems. So in this slide, I will be focusing on what are the different types of sensors that are used in your ECU. Because in the exam, there might be a question that write a short note on this particular sensor. So what are the sensors that we are going to use and we are going to study? See, first is the mass airflow sensor. In the name itself, you know what are you measuring? You are measuring the mass of the air which is flowing into the engine. means where this will be inside the intake manifold, right? Because the intake air is coming inside the intake manifold only. So this sensor will be inside the intake manifold. The second sensor is what? Engine speed sensor. It is measuring the speed of the engine. Third sensor is the camshaft position sensor. It is measuring what? It is measuring the position of the camshaft. Fourth is crankshaft position sensor. It is measuring the position of the crankshaft. Fifth is a knock sensor. Knock sensor is kind of a sound sensor which measures what is the amount of sound being produced inside the engine. If it is higher than a certain limit, then it says that the engine is knocking. Knock sensors can also measure the vibrations of the engine also. Depends on the manufacturer. But it basically measures what is the whether or not knocking is taking place inside the engine. Then there is intake air temperature sensor. It is measuring the temperature of the intake air. Then there is intake air pressure sensor. It is measuring the pressure of the intake air. Then there is exhaust gas oxygen sensor. This sensor is also known as lambda sensor. Okay, lambda, LAMBDA. It is measuring what is the amount of oxygen in the exhaust gases. So thus these various sensors collect all this information and send it back to the ECU, right? So we will see these sensors one by one, how they work and what is their function and all that. So see, first sensor that we are going to see is the throttle position sensor. What is this sensor going to do? It is going to measure the position of the throttle, right? In our traditional engine, what happens? In our traditional engine, whenever we press the accelerator, the throttle moves, right? However, see, where is the throttle located? Throttle is located inside the intake manifold, in the beginning of the intake manifold, right? Over here, there is throttle. If you press accelerator less, the throttle is in semi-closed position. If you press the accelerator very much, the throttle will be in open position and all the intake charge will go into your intake manifold. Here only some amount of charge will go. Basically, why do we need a throttle position sensor? See, in case of your engine, in case of a direct injection engine, right, you are going to directly inject the fuel into the engine. How will the engine know whether or not you are accelerating or whether you are cruising? If you are accelerating, what are you going to do? You are going to hit the accelerator pedal downwards. In that case, what should the engine do? Engine should increase the amount of fuel that is being injected. But if you are only cruising, that is the throttle, that you have not pressed the accelerator pedal directly to the bottom, you have pressed only a little bit, then what should happen? Then it should not, then the amount of fuel injected should be less. That is why we need a throttle position sensor. Throttle position sensor is used to determine how much amount of fuel, throttle position sensor is used to check how much is the accelerator pedal pushed downwards. And based on how much the accelerator pedal is pushed downwards, many things can be controlled. One of these things is the amount of fuel, but many other things can also be controlled, right? So throttle position sensor is used to measure the current position of the throttle. So how does the throttle position sensor work? See, throttle position sensor, and for that matter all sensors, work on the basic principle of voltage divider. Okay, first I will explain to you what voltage divider is. See, this is not necessary for exam point of view, but voltage divider will be required in your future. Definitely it will be required. See, what does a voltage divider circuit do? In voltage divider circuit, there is first of all fixed voltage. Here is 5 volt, here is ground. Okay, between these, here you connect your sensor. This is your sensor. A sensor is basically, in most cases, not in most but in large number of cases, sensor is a device whose resistance changes with the changes in external conditions. I will repeat, in our automobile sensors, most sensors are devices whose resistance changes because of the change in external condition. So let us say that this is a variable resistance. Then we fix a fixed resistance over here. Okay, and between the variable resistance and fixed resistance over here, we connect a wire, and this wire goes to your ECU. Okay, this wire goes to your ECU, right? ECU. So what is basically happening? This voltage is fixed. Imagine that if this resistance is very less. If this resistance is very less and this resistance is very high, the voltage drop from here to here will be less, right? Imagine from 5 volt it goes to 4 volts. Then this 4 volt signal will be sent to the ECU. But imagine if because of some external condition, the value of this resistance increases. This value of resistance increases very much. What will happen? The voltage drop over here will increase. If the voltage drop over here increase, what will be the voltage over here? From 5 volt, let us say it becomes 1 volt. Then this 1 volt signal will be sent to the ECU. Thus, because of the change in external condition, there is a change in resistance of this sensor. Because of the change in resistance of this sensor, there is a change in voltage over here. And this voltage signal is sent to the ECU. And the ECU, based on this signal, determines what is the value of that external condition. Okay, so that is what basically happens in most of our sensors. So in case of a throttle position sensor, see, if this is your throttle plate, see, this is your throttle plate. This is a throttle position sensor. There is a moving arm inside the throttle position sensor. This moving arm will be somewhere over here. As the throttle moves, this arm moves like this, clockwise, anti-clockwise. Okay, as the throttle moves, this arm will move like this. Okay, and based on the movement of this arm, what happens? See, that is this arm. This arm is moving. This arm is moving like this and this. Okay, so what happens? This is your fixed voltage. This is your ground. This is your sensor. This is your sensor resistance. This is your fixed resistance. And this is the signal that is going to the ECU. From here, the signal is going to the ECU. Right? So what is going to happen? See, initially imagine that the throttle is not open at all. So the arm is over here. What is happening? The resistance is very less over here. So what is going to happen? All the voltage is going to go over here and from here to here. Because there is no resistance over here, this 5 volt will be sent to over here 5 volt. There will be some voltage drop over here and then this will be 0 volt. So this signal is 5 volt. Okay, this is when the throttle is in absolutely closed position. What happens if you press the throttle lightly? This will go till here, right? Voltage will come from here. It will go through some resistance. There will be some voltage drop. Then it will go through this. So there has been some voltage drop because of this resistance. Let us say this is 2 volt. So this 2 volt signal will be given to the ECU. Okay, this 2 volt will go through resistance and ground. And imagine if this is completely over here. It is going through all this resistance. There is a large amount of voltage drop over here. So the voltage over here is very less. It will be something like 0.1 volt. And this signal will be sent to the ECU. Right? Thus what is happening? Basically what is happening? Because of our accelerator pedal, this throttle plate is rotating. Because of the rotation of this throttle plate, this moving arm is rotating. Because of the rotation of this moving arm, this resistance is changing. This resistance is changing. Because of the change in resistance, the voltage over here is changing. Because of the change in voltage over here, the signal to the ECU is changing. And this is how the throttle position sensor works. Okay. Next is our coolant temperature sensor. What is the function of coolant temperature sensor? It is used to measure the temperature of the coolant, right? Why is it necessary to measure the temperature of the coolant? See, by measuring the temperature of the coolant, we can guess the amount of heat that is currently being rejected by the engine. So we can calculate the amount of heat absorbed by the coolant. See, in our heat balance sheet, we had to measure what is the amount of heat absorbed by the coolant. So there we require a coolant temperature sensor. This coolant temperature sensor measures the amount of heat rejected by the engine, and thus it can be used to estimate what is the temperature of the engine, right? So see, how does the coolant temperature sensor work? Coolant temperature sensor basically works similar to an RTD. What is an RTD? RTD is resistance temperature detector, right? How does the RTD work? RTD is made up of a material whose resistance changes with change in temperature. Again I will repeat, RTD is made from a material whose resistance changes with change in temperature. So initially when the temperature of the coolant is very low, okay, when the engine is stationary, engine is not working, engine is off, the temperature of the engine is low, hence the temperature of the coolant is low. Hence what happens, the resistance of this coolant temperature sensor is also low. So what happens when the voltage comes, there is some voltage drop over here, there is some voltage drop over here, and this signal is being sent to the ECU. Because the resistance over here is less, what is going to happen? Certain amount of signal is going to be sent to the ECU. What will happen afterwards? Afterwards, when the engine warms up, engine heats up, the coolant will also get heated up. Because of the heating up of the coolant, resistance of the coolant will also change. And because of the change in resistance of the coolant, the signal sent to the ECU will also change. Thus basically what is happening, because of the change in temperature of the coolant, there is change in resistance of the engine coolant temperature sensor. Because of the change in resistance of the engine coolant temperature sensor, there is a change in the voltage drop, and because of the change in voltage drop, that voltage signal is sent to the ECU. And this is how you can measure the temperature of the engine coolant. Why is it necessary to measure the temperature of the engine coolant? See, by measuring the temperature of the engine coolant, we can control the amount of coolant flow in the engine by accurately controlling. See, for example, when the engine is cold, there should be no coolant flow into the engine, right? Because we need the engine to warm up quickly. As the engine gets warmed up, we can increase the coolant flow, right? That is how we can accurately control the engine temperature and get the maximum efficiency from the engine. The inlet air temperature sensor works on the same principle as the coolant temperature sensor. The difference is coolant temperature sensor measures the temperature of a liquid, whereas inlet air temperature sensor measures the temperature of the inlet air. Okay, inlet air over here. So the function of both is the same. Inlet air temperature sensor also works on the same principle of RTD, right? This inlet air temperature sensor is placed inside the intake manifold, and over there we can measure the temperature of the inlet air, and by measuring the temperature of inlet air we get a lot of information. The inlet air temperature sensor can also is generally used with a mass airflow sensor. I will come to that afterwards, but you have to remember, if you have asked to write a short note on inlet air temperature sensor, you have to draw a similar diagram, okay, a diagram which is similar to this. I haven't drawn it because the working of both is same, but if you have to explain only one, then you have to draw this, okay. So that is your inlet air temperature sensor. See over here. Okay, here you can see in this what is happening. In this case, as the temperature is increasing, in this case there is a decrease in resistance. See, the temperature over this sensor, see, there are two types of I can say temperature changes. There can be NTC and there can be PTC. One is negative temperature coefficient, one is positive temperature coefficient. In case of negative temperature coefficient, as the temperature increases, the resistance decreases. In case of positive temperature coefficient, as the temperature increases, the resistance increases. Okay, so this is an example of NTC, negative temperature coefficient. Okay, so using this, see, as the temperature changes, there is a change in resistance, and as there is a change in resistance, there is a change in voltage value. This voltage value is then sent to the ECU, which based on this voltage value determines what will be the temperature of the coolant. Okay, so this is how inlet air temperature sensor works. Now mass airflow sensor. See, mass airflow sensor and engine coolant temperature sensor, both are placed inside the intake manifold. Why are both placed inside the intake manifold? Mass airflow sensor is used to measure what is the mass of incoming air into the intake manifold. This will then be sent to the engine, intake manifold of the intake port of the engine. Mass airflow sensor measures the mass of intake air, and intake air temperature sensor measures the temperature of the intake air. Okay, both these sensors work together. Now see, first of all we will see how the mass airflow sensor works. See, mass airflow sensor also uses the similar principle as RTD. Okay, what do we do in mass airflow sensor? In mass airflow sensor, we use the hot wire method. What is a hot wire method? See, this is your hot wire. This is your intake manifold. This tube-like thing is your intake manifold. Intake air is coming from the atmosphere. From here, air is coming. It is flowing and it is going to the engine. Okay. As the air flows over this, even you can imagine, as the air flows over this, what is going to happen? Air is going to come in contact with this wire. This wire is heated to at a higher temperature. Let us say 100 degrees Celsius. Okay. It is heated to some higher temperature. As the air will flow over this wire, what is going to happen? Because of airflow, there will be convection. Because of convection, this wire will lose heat, and as the wire loses heat, it will cool down. Just now you know, as the temperature changes, there is a change in resistance. So there will be a change in resistance of this wire. As soon as the wire resistance changes, we can calculate what is the change in value of resistance by measuring what is the change in value of voltage. Okay, in this case we are using a galvanometer and this Wheatstone bridge to measure, but you can also use a simple voltage divider circuit also. Basically, what is this entire circuit used to measure? This entire circuit is used to measure what is the change in resistance of this. Why is the resistance changing? The resistance is changing because of the airflow. More the airflow over the wire, more will be the temperature drop. Less the airflow, less will be the temperature drop. Thus, by measuring the flow of air, we can estimate what will be the amount of air that is coming inside. By measuring what is the temperature change over here, we are measuring what is the amount of air coming onto this, and by measuring what is the amount of air coming onto this, we can measure what is the total amount of airflow. Okay, this is how your mass airflow sensor works. But see, often with mass airflow sensor, there is always a temperature sensor, right? What is the function of this temperature sensor? See, air can be, see, if there is air at 40 degrees Celsius, and there is air at 0 degrees Celsius. Same quantity of air is flowing through this. Okay, same quantity of air is flowing, but some air is, but in one case air is at 40 degrees Celsius, and in one case air is at 0 degrees Celsius. So the amount of cooling that is produced over here will be more in case of 0 degrees Celsius, because air is at a lower temperature, it will absorb more amount of heat. But if air is at 40 degrees Celsius, it will absorb less amount of heat. Thus, based on the temperature of the intake air, the amount of cooling produced will also vary. That is why a temperature sensor is required to calculate this more accurately. So that is how a mass airflow sensor works, right? The next is a crankshaft and camshaft position sensor. Now this is a different kind of a sensor than all the sensors that we have seen till now. In all the sensors that we have seen till now, we use the voltage divider circuit. There was a change in resistance, then there was a corresponding change in voltage, and we measured that corresponding change in voltage. In crankshaft and camshaft position sensor, see what happens. See over here you can see this is a toothed wheel. This is a geared wheel or toothed wheel. That is, the wheel has teeth on it. And there is a sensor. This is a sensor which senses these teeth. This sensor is used to sense these teeth. Okay. So how does this system work? In this system, see, I will show on this type. See what is happening as the engine is rotating. Say, let us say crankshaft. Okay, both work same. Crankshaft, camshaft position sensor, both work in the same way. Let us see for one thing. Okay, imagine there is a crankshaft position sensor. On the crankshaft, you will put this gear teeth. This gear teeth will be on your crankshaft. Near the crankshaft, there will be a sensor. This sensor senses these teeth. Okay, this can be an eddy current type sensor or inductive proximity sensor. Okay, it can be either one of two. That doesn't matter, but it will sense these teeth. So what happens? See, when this teeth comes in front of this sensor, it will sense this teeth, right? It will send a signal to the ECU that I have sensed a tooth. Okay, then what is going to happen? This is going to rotate, let us say, in the anti-clockwise direction. So after this tooth, what is after this tooth, it has sent a signal to the ECU. Let us say this is the signal that it sent to the ECU, that there is a tooth in front of me. What is going to happen? Then this crankshaft is going to rotate. Because of crankshaft, this teeth is going to rotate, and after this tooth comes in front of the sensor. Between this and this, there is no tooth in front of the sensor, hence there is no signal. When this tooth comes, there is another signal produced. Again, when there is no tooth in between, there is no signal. Again, when there is a tooth in front of the sensor, another signal is produced. Thus, whenever a tooth comes in front of the sensor, a signal is produced, right? And by measuring the time between these two sensors, we can measure the time between these two sensors, and we know what is the angle between these two tooth. See, for example, if you have 360 degree, this is 360 degree, na, complete circle. If you have 36 teeth, then it will be 360 divided by 36. So between each tooth, what is the angle? Angle is 10 degree. So by measuring the time between these two, we can estimate what is the RPM of the engine. Thus, by measuring what is the time taken between two teeth, we can measure the speed of the crankshaft and camshaft. This is how we will measure the engine speed. But how to measure the engine position? To measure the engine position, what do? There are some missing teeth over here, right? So what will happen when this comes? See, there are continuous teeth over here. It is a continuous section. So there will be a continuous signal sent to the ECU. When the ECU receives this continuous signal, it knows that at the start of this signal, at the end of this signal, this is my 0 degree. This is my 0 degree of the crankshaft. So when the next signal comes, it will know that this is 10 degree. When the next signal comes, it will know that this is 20 degree. When next signal comes, it will know that it is 30 degree, and so on. So what is the ECU doing? ECU is just receiving the signal. It will receive one long signal, and over here it knows this is 0 degree of the crankshaft. Then this signal means 10 degree of the crankshaft. Okay, and this is how it can measure the position of the crankshaft. And accordingly, it will open and close the valve. It will do many kind of things. That depends on the ECU, what it is going to do. But this is how the crankshaft and camshaft position sensor works. Both work in the same way. This can be put on this geared wheel can be put on the crankshaft, and another geared wheel can be put on the camshaft. There will be one sensor for crankshaft and one sensor for camshaft. Okay, so this is how this works. Next thing is your exhaust gas oxygen sensor. Now this is the last sensor, and this is by far the most difficult sensor that you have. If you have this in your exam, then you have to draw this diagram. See, this diagram must be drawn by you. First, I will explain why an exhaust oxygen gas sensor is required. See, basically we have to measure the amount of oxygen in the exhaust gas itself. Why do we have to measure the amount of oxygen? See, whenever there is a catalytic converter used, what does a catalytic converter do? A normal oxidation catalytic converter does two things. It oxidizes carbon monoxide to CO2, and it oxidizes your unburnt hydrocarbons to CO2 and H2. Thus, what happens? Your catalytic converter must have excess amount of oxygen present. Only when the catalytic converter has excess amount of oxygen, then only oxidation will take place. Now, hence we have to measure what is the amount of oxygen present in the exhaust gas. If the amount of oxygen present in the exhaust gas is less, then we have to reduce either the fuel injection, we have to reduce the amount of fuel injected, or we have to increase the amount of intake air. That is why exhaust oxygen gas sensor is used. Basically, an exhaust oxygen gas sensor is used to ensure that there is sufficient amount of oxygen inside the exhaust gas for the catalytic converter to work properly. Right? So how does an exhaust oxygen gas sensor work? See, exhaust oxygen gas sensor is made up of a ceramic material. Generally, the ceramic material is zirconia dioxide. It consists of this U-shaped kind of thing. Okay, this U-shaped kind of thing, and it has two parts. It has an outer layer and it has an inner layer. Okay, the outer layer is made, outer and inner layer both have deposited on it platinum. Okay, it is platinum, very fine platinum is deposited on the inside layer also and the outside layer also. What happens? See, the inner part is open to atmospheric air. Inner part is open to atmospheric air. What is the concentration of oxygen in atmospheric air? 21%. So the concentration of oxygen on the inner side of your ceramic material, the concentration of oxygen is how much? 21%. Okay, this is your exhaust gas. From here, this is your complete exhaust is coming from this. Okay, the engine exhaust is going through this tube. So exhaust gas is flowing over this, right? As exhaust gas is flowing over this, there will be some amount of oxygen in the exhaust gases. If the amount of oxygen in the exhaust gases, let us say for some reason no combustion is taking place inside the engine, and if the concentration of oxygen in the exhaust gases is also 21%, what does that mean? Here also it is 21%, inside also there it is 21%, means oxygen quantity is same. In that case, there will be nothing done by the exhaust oxygen gas sensor. Okay, but what happens if the oxygen, here the oxygen quantity is always going to remain 21%. Okay, but imagine if here the oxygen quantity is less. Imagine here the oxygen quantity is only say 5%. What is going to happen? This zirconia dioxide and this platinum, these both materials are such that because of these materials there will be a voltage difference generated across the inner side and outer side of this ceramic. Again I will repeat, because of the difference in concentration of oxygen on either side of the ceramic material, because of difference in the concentration of oxygen particles on either side of the ceramic materials, there will be a voltage difference generated across these two, across the inner side and the outer side. Why? Because oxygen will lose an electron and it will become positively charged. Okay, oxygen will lose an electron and this electron will flow from the outer side to the inner side. Thus there will be a voltage difference. There will be a voltage difference over here. This voltage difference will be directly proportional to the difference in concentration of the oxygen particles. What does that mean? If there is more oxygen difference, then the voltage generated will be greater. That is measured using this voltmeter, right? So that is basically what is happening over here. Because of the flow of electrons and the negative oxygen particles, there is an voltage difference across these two plates, and this voltage difference across these two plates is directly proportional to the difference in concentration of the oxygen, right? So that is how exhaust oxygen gas sensor works. Exhaust oxygen gas sensor is also known as lambda sensor. Okay, so these are the different kinds of sensors that are used in automobiles. You should know the working of each sensor and you should know the diagram of each sensor for your exam. That is all that is actually required from your side.